Swayam Prabha. Digital India. Educated India.
I will take two types of maneuver. One is steady side slip. Okay. What is the meaning of steady side slip? You know what is the meaning of side slip? Suppose this is the central line on the airstrip. Okay. And if you are landing like this, then what is the side slip angle? I am just going like this. Side slip angle? 0. Suppose if I go like this. So I am actually landing like this, moving like this. Then side slip is what? Then in this configuration, side slip is positive because by convention, side slip angle is this angle. When the relative wind comes from the right side of the pilot flying. So this is a positive side slip. Right? Clear? So what we will do in a steady side slip, the maneuver would be, I will be flying the machine, I'll bank it and I'll give appropriate rudder correction, and I'll be flying like this at a constant beta, at a constant speed. Right? That is a steady side slip maneuver. And second, we will also do something called steady coordinated turn. What is the steady coordinated turn? I am flying like this, I will bang the airplane, and I will turn like this without losing the altitude. So every time, what is the value of beta? It is aligning with the velocity vector. So what is beta? So every time beta is 0. Is this part clear? When I am talking about steady coordinated turn, I bang, I turn like this without losing the altitude. So this maneuver will have beta equal to 0. This beta equal to 0 will be seen at the center of gravity of the airplane. And suppose if you are taking a steady coordinated turn, beta is 0 at CG, because turning about the CG like this, right? Here is beta 0. But if you put a sensor, say angle of attack vane or side slip vane somewhere here, then at this point beta is not 0. Because at this point, whatever turn rate is there divided by speed, you can find out what is the beta. But when you are talking about steady coordinated turn, beta 0 means beta at the center of gravity. So whatever instrument you will put at the nose tip of the wing tip of the airplane, there it will not record 0. You have to give a correction. Okay. So these two maneuvers will execute and have already perhaps executed in ANSA. Let us see how can you understand using the flight test data. First we will take steady side slip. Here beta is not equal to 0. Correct? It's moving with a constant beta, that is, it is flying like this, constant beta. Okay? And if you recall your sixth of equations, the Fy, force on the y direction will be mg sine phi, let's write this, plus half rho v square s into cy beta into beta plus cy p into pb by 2v 2v plus cy r into rb by 2v plus cy delta r into delta r. What is cy here? What is cy? Please do refer my earlier lecture. CY, so this is the x-axis, this is the y-axis, Z is into the board, right? Okay. CY means the force which is acting on the y direction. Right? Moving Fx, then force in the y direction is Fy, and if I non-dimensional Fy by half rho v square s, I get Cy. So when I am going for a side slip, this is the general equation. This Fy, to see that side force will come because of, if I am banking the airplane, then mg sin phi component will be there along the y direction, that component is there, and is the aerodynamic force. Okay. Once you know this, when I am talking about steady side slip, so I am ensuring that net force is 0. Okay. So I ensure through rudder and everything that net force is 0. So I write 0 equal to mg sin phi. I adjust the throttle accordingly, equal to half rho v square s Cy beta into beta. Will there be contribution from this term? This term comes when there is a roll rate. If I am doing a steady side slip, what is the value of P? 0. Is 0, so I drop this. What is the value of R? R is the yaw rate. It is only going like this. What is the value of R? 0, I drop this. And there is a rudder deflection delta R. So I write Cy delta R into delta R. You may ask, why not Cy delta A? There will be some small value of Cy delta A, very, very small, but we are neglecting it because it's not that significant in y direction force. Okay, so this gets simplified to this. Now what I do, I divide left hand side and right hand side by half rho v square. So I get 0 is equal to mg by half rho v square s sin phi plus Cy beta into beta plus Cy delta R into delta R. Okay? Can you add some more information how to improve this term, how to make it more explicit? What is mg by half rho v square s? It is a CL, lift coefficient. So I can write from here, I can write 0 equal to CL sin phi plus Cy beta into beta plus Cy delta R into delta R. Any objection up to this point? Allow me to erase this part. Further simplification I can do if I am doing a small bank, right? I do not give a 60 degree bank and do steady side slip. Let's say within 10 degrees, 15 degrees bank, I am doing a steady side slip. Then I can do the approximation sin phi equal to phi, right? Within 10 to 15 degrees. So for small phi, by the row angle, the bank angle, where 0 is equal to CL phi plus Cy beta into beta plus Cy delta R into delta R. Now tell me, in the respect the right hand side, how many things you can measure through experiment? Can you measure CL? CL, yes, here I know. CL is 2W by rho v square s. I do measurement, I get speed from airspeed indicator, then I correct it. S is the wing area. So CL I know, no problem. Phi, from turn back indicator I get. Beta, I get from angle of attack boom, which comes to the laptop in our case. And delta R also, we know that through potentiometer based deflection, we measure it in a laptop. Hansa, how many are flying? Flown Hansa. So you have seen that delta R coming, phi coming, right? Fine. Of course, this is a message for those who are doing the certificate course. You should send a request to NPTEL, copy to me. If you want to do the experiments here, we can make arrangements for you through NPTEL, right? I'll explore that possibility. So I know one thing, I have taken the force equation from a standard fixed off model, right? I have done approximation, I have got a simplified equation. I am doing experiments and I know that I can measure on this mark parameter or variable. Okay. Now let us ask one question. When I talk about rudder, what is the role of rudder? To give force or to give moment? Primary role. Primary moment with small area but large moment arm. Right? Okay. That is why you will find Cy delta R, and if you compare Ca delta R, that is why when you compare Cy delta and Cn delta, this is a strong derivative. Okay. However, this is relatively weak derivative. Relatively. And you can understand because rudder is meant to give more moment. That is why large, long moment on this there. So if I again do this slight approximation, then what I get? I get 0 equal to Cl5 plus Cy beta into beta, and this term I am neglecting. Under this assumption. This is an approximation, quick approximation. Then what I get from here, if I say this, I get Cy beta is equal to minus Cl phi by beta. No objection here? From this equation I can get this. What are we getting? So that if I execute a side slip maneuver, I know the value of Cl, I can measure phi, I can measure beta, then actually I am estimating the value of Ci beta for the whole airplane, which is approximate one, right? What are the caution is, you use an airplane which doesn't have a very high rudder area or high rudder effectiveness. In a sense, the Cy delta should not be very large. In good design, this is weak derivative, this is strong derivative. Under that approximation, you go for a steady side slip and measure what is phi, what is beta, find that ratio, multiply with Cl, the value, numerical value will be Cy beta. You are getting that estimate. These tests are very important when you do some minor modification in the vertical tail. Suppose some minor changes there, right? You only do steady side slip maneuver, you get how much Cy beta has changed. For marginal. Otherwise, you go for a thorough flight test experiments, which are rigorous. Another thing as a experimentalist, you should know what is the sign of Cy beta coming from this relationship. What is the sign you are getting from this? Sign is what? Phi is positive, because beta is positive, then Cl is positive, so it is negative. Cy beta is negative, right? Cy beta should be negative. Now let us see for an airplane whether Cy beta is negative or not. Typically, side force when there is a beta comes from the vertical tail, isn't it? Wing may not give, normal wing may not give any side force. Little bit of fuselage will give. So if this is the airplane, if the airplane is side slipping, so air is coming from here, so it will experience a force in this direction. But as per the convention, this is x and this is y. So this direction is positive or negative? Negative. So Cy beta is negative. So it is consistent. Do you see how beautiful is this experiment? Those who have got a Hansen data, please share with everybody and try to get the value of Cy beta. Is it clear, everybody? Share that data. Let us do some more data extraction, physics based, right? You know the Cn, we have understood Cn is Cn beta into beta plus Cn p into pb by 2b or 2u plus Cn r into rb by 2u plus Cn delta r into delta r. Right? This is the Ewing moment coefficient I am expanding, assuming things are linear, right? Using the partial derivatives, which are called aerodynamic derivatives, non-dimensional aerodynamic derivatives or parameters. Now, if I am doing steady side slip, So now let us see if it is a steady, that means it is steady side slip is going like this, airplane. What is the value of Cn? Is there any yawing moment? If there is a yawing moment, it will turn. That is going like this. So any yawing moment is there? So what is the left hand side? Becomes 0. So Cn beta into beta, yes, beta is there because it is going steady side slip. What about this term? Is there any P? When it is moving like this, is there any P? P, if there is a P, it will roll like this. It is moving like this. Is there any P? So this term goes to 0. Is there any R? Goes to 0. So I have got this plus Cn delta R into delta R. Actually, when I expand Cn, you should also put Cn delta A into delta A. This is yaw moment because of aileron deflection, maybe smaller. What is this term? Cn delta A into delta A. How can there be yaw moment with aileron deflection? Huh? Say, imagine this is the wing, right? I have deflected the aileron here down and then up. So which way it will bank? Down, up. Like this. As it moves like this, which wing is having more lift? This man. Which wing is having more induced drag? So what the plane will do? Yeah. Cn because of delta A. That is Cn delta A. You can understand that is much less compared to actual Cn delta into delta or Cn delta R into delta. This is a typically we call adverse yaw. It is good to put that initially and then we can assume that that is neglected. Now we understand this is adverse yaw effect and we can, for engineering approximation, we can neglect that. That is why this part has also been taken as 0. That should be clear, right? Now if I use this relationship, I get a equation beta by delta R is equal to minus Cn beta by Cn delta R into no, reverse. It will be Cn delta R by Cn beta. The Cn into beta plus Cn delta and that equal to 0. So this is the relationship we get. Right? Let me again recapitulate. This relationship we have got by simplifying a standard Sitzdorf equation under the assumption the aircraft is executing steady side slip. Because it is executing a steady side slip, we are putting P0, R0. Also we have neglected adverse yaw effect. So this term has been dropped. Under those assumptions, we got equation 0 equal to Cn beta into beta plus Cn delta R into delta R. And if I further simplify this, I get beta divided by delta R equal to minus Cn delta R by Cn beta. Now what is the sign of Cn delta R? It's negative. Very good. So this is minus. This sign is negative. What about Cn beta? For a statically stable airplane? Positive. So this ratio should be what? Positive. So ratio of beta and delta should be positive. Now tell me, if I am flying beta 0, I want to give a radar deflection so that I start doing beta. How do I do that? What does it say? If I want a positive beta, I have to give a positive delta. Right? What is positive delta? Towards the left. Do you see how this, are you able to extract this? No. Let me, please understand this. This is very important when you do an experiment. What is happening? What is the equation studying? Be careful, right? Okay. This is the airplane. Okay. If there is a beta, what this airplane will do? Since this is statically stable in directional case, for a positive beta, it will give a positive yaw moment. So this sign will be positive, that is Cn beta into beta. This contribution will be positive. But you want to hold that such that beta is constant. So you have to nullify this beta, Cn beta into beta. That moment will remain. So you have to give what type of moment? Negative moment. Who will give that moment? Radar. How much radar gives? Cn delta R into delta R. This sign should be what? Positive or negative? Cn delta R into delta should be negative. But you know, Cn delta R is Positive or negative? So let us look here. As the airplane sees a beta, airplane being laterally statically stable, it will generate a positive moment, which is Cn beta into beta. But if you want to hold it for beta constant, this moment has to be put to 0. Because it should go like this. But because it is directionally stable, as there is a beta, you try to turn. It will become beta 0. You have to hold this beta. That means I have to apply a counter moment equivalent to this contribution. Since this is positive, I have to give a negative moment. And Cn delta R into delta R, sign is negative. Okay. So I have to give delta R which sign? Positive. So I have to give delta R positive. So that is how I study. If the radar is there and it has to be left, towards left. So what we are seeing for a positive beta, I must give delta R positive. Correct? And that is exactly you are getting from here. Ratio of beta by delta R is also positive. So whatever equation of motion you have developed, through flight test you are finding it is consistent, it is making sense. Is there any doubt in this? Anybody having doubt?
No, sir.
Okay. Now the question is, how best I can use it? Generally you will find, suppose you have changed the vertical tail for the airplane. Minor changes, right? And Cn delta R being a strong derivative, and Cn beta being a strong derivative, this ratio is extremely important, right, for directional case. So if you attribute, okay, Cn delta change will not be much, right? So I can measure beta, I can measure delta R by doing a different steady cycle maneuver, beta 2 degree, beta 3 degree, beta 4 degree, beta 5 degree, and then knowing the same delta R value, I can find out what is the new value of Cn beta. So you get an approximate variation. Whether this change has caused large variation or not, that is important. And if it is not, fine, you carry on with this, otherwise you go for a huge flight test, whatever exercise is there. So do you understand? Though it's a simple approach, how beautiful this can be used to develop engineering skill, to extract information based on the physics, based on the equation of motion, what you understand. Is it clear? Okay. So that was the purpose of this. I request all of you to use the Hansa data and do this exercise.